Is this one. You can read very easily. What is magnetic field due to current carrying conductor, right?
Yes, sir.
Is it visible? Yeah. Very simple demonstration. You can see very easily. This is the circuit, right?
Yes, sir.
In this one, we have one battery, one resistance. And these are iron. You have the idea what exactly these are called?
Iron filing.
Yes, iron filings. And if I pass through the current, what happens now you can see. Shall I?
Yes, sir.
Okay, I increase the current. Now zero current, right?
Yes, sir.
Now you look at these iron filings. Now I am any change?
Yes, sir. It became more cyclic.
Right, they became more cyclic, or I can say they are in regular arrangement, right?
Yes,
This
sir.
is random arrangement. They are randomly oriented, not arrangement, exactly to say these are oriented, randomly oriented iron filings. But if I pass through the current, suppose I gradually increase the current, all right? Now you
Yes,
look
sir.
at it. Now they are not all perfectly aligned or perfectly oriented. I am
Yes, sir.
increasing the current gradually. Now they are getting more and more aligned in a circular shape, right?
Yes, sir.
Now I am applying a large current. Almost all of the iron filings are taking up the spiral shape, right?
Yes, sir.
Circles, or I can say concentric circles. That is what on the right hand side is depicted, right?
Yes, sir.
Arrow is the current direction. Arrow is the current
Direction.
direction.
Yes, sir.
Whatever that is circulating around that arrow is orientation of the iron filings, right?
Yes, sir.
Why they got oriented? What exactly that mean? When do they get aligned? Iron filings, what is their actual property? These are
Yes,
the
sir.
questions you can have, right?
Yes, sir.
Okay, what is the property of iron? Iron, in presence of any magnet, they get attracted, right?
Yes, sir.
Isn't it?
Yes, sir.
If not attaching to the magnet, they will align. You might have observed this one. Take any steel pin, right? Have magnet in your hand so that you can make that pin or needle steel will be oriented at any angle, right?
Yes, sir.
Even you can make it float by few millimeters. If you are good at experimenting physically, you might have done, I don't know exactly. We played a lot more with magnets. You ever played with magnets?
Yes, sir.
Definitely you might have done that experiment, right? So this is what it happens when iron filings are kept under magnet. So take iron filings on the top of any pad and then use your any small magnet keeping below the pad and then move it, and then iron filings will move whatever the direction you move the magnet, right? If you
Yes, sir.
rotate the magnet, what will the iron filings do? What will they do? Hello?
Yes, sir.
What will they do? Iron filings. If you move the magnet, if
They will go back to normal.
rotate the magnet.
They'll change direction.
Okay, suppose you have a pad. On the top of the pad, you put some of the iron filings, and below the pad you have a magnet, and then rotate the magnet, right?
Yes, sir.
How do the iron filings move? Do they rotate or they will move away?
They will move away, sir.
Move away or they move along the
They
circular
move
path?
with the magnet, sir.
So if you are rotating means they will be moving in the circular path, right?
Yes, sir.
Okay, now you see the path of the iron filings, right?
Yes, sir.
It indicates that magnetic field is in which direction? It is in a circular path, right?
Yes, sir.
Okay, circular path. It means that at each and every point, there is change of direction of the magnetic field. We already observed circular in mathematics. For circle, tangent changes
Yes,
its
sir.
direction at each and every point on the circle, right?
Yes, sir.
So the direction of the tangent direction is nothing but the direction of the or orientation of each and every iron filing. So iron filings will be indicating the tangent direction at that particular position. But anyhow, magnetic force V is along a circular path, not in a straight line path. If it is a straight line path, all the iron filings might have aligned along a straight line, isn't it?
Yes, sir.
So if you drag the magnet, they will move along. If you rotate, iron filings rotate. So with this one, now if you want, you can see the, right?
Yes, sir.
You can see the direction of this, right?
Yes,
Compass.
sir.
Direction of the compass is changing or not? Is it changing?
Yes, sir.
So at each and every point, the magnetic force direction or direction of the magnetic force is different, right? This
Yes,
is
sir.
possible only when the force is acting along the circular path, or I can say each time the force is along the tangential direction, right?
Yes, sir.
Okay, this is the point. Who is the person first observed all this?
Sir, I did not get you, sir.
Do you remember the name of the person who identified this one?
Fleming, sir?
Fleming?
Yes, sir.
Ampere?
Yes, sir.
Ampere or Fleming? Or any other one?
I think Fleming, sir.
Okay. I don't want to reveal now itself, but we continue this further and then you can understand. This is more, yeah, how many possible things are there in this one? You can change the current, right? Now you just switch on and switch off.
Yes, sir.
This is the complete 3D. You can rotate and see.
Yes, sir.
So what is the magnetic field produced? That number is also here. On the bottom, you can see the value of the magnetic field it produced, right? So
Yes,
what are the different things that are affecting? You go to settings. Okay, now increase the current. And then you can see what is the effect of increasing the current. Or you can see what is the effect of reversing the current direction. Any change you observed?
Yes, sir.
Even the iron filings
Yes, sir.
got their direction reversed, isn't it?
Yes, sir.
So if there is no current, randomly oriented iron filings. This is the positive current and this is negative current. You can see the current direction, blue arrow, right? This is upwards and this is downwards. What is this brown? This brown indicates a conductor. You already know what is a conductor, what is a non-conductor, right?
Yes, sir.
We discussed about these properties in electricity, right?
Yes, sir.
Yeah, you can look at the field lines. You can see how the field is. What is the field lines? How they are looking out? They are concentric rings, right?
Yes, sir.
As we move away from this line or this brown, these lines are getting distant and distant and distant, right?
Yes, sir.
So the separation between this one is getting reduced as we move closer to this conductor, right? What exactly this
Yes,
means?
sir.
This means the magnetic field is high at positions which are very close to the conductor, right?
Yes, sir.
Okay, these are the observations you can make, and you can see the field intensity, right? This arrow indicates the field intensity or force, right? What is
Yes,
the
sir.
direction it is showing? You can clearly see. What is the direction it is showing? Is it tangent to that circular or not? Right?
Yes, sir.
So what is the direction of magnetic field? It is always tangent, right?
Yes, sir.
You want to see at other location, other point, so that will be confirmed.
Yes, sir.
Yeah, now I have. Can I change the location of this? I can. Okay, is it visible?
Yes, sir.
Look at the direction of the magnetic field, right?
Yes, sir.
This is radius, right? We discussed this one in the properties of circles. This line and this line will be perpendicular to each other because this is the tangent line, this is the radial vector or radius. Radius and tangent will be perpendicular to each other. Now you can see both, or from this side it will be very clear, right?
Yes, sir.
Clear?
Yes.
So what is the direction of magnetic field? It is along the tangent to the circle or electric field, right? Lines.
Yes, sir.
These are the electric field lines. They are circular, concentric circles. Now you can see whether there is a magnetic field or not. I am trying to change the direction of the compass, right? But
Yes, sir.
once again, it is getting aligned towards this direction. North is in this direction, means definitely this is north of the or direction of the force, isn't
Yes.
it? Even I am
Yes.
trying to disorder, but once again that compass is getting aligned towards the magnetic force. That clear indication of magnetic force along the tangential direction, right?
Yes, sir.
Okay, what is the height? If I move along that height, do you find any change in the magnetic field? That arrow, look at the arrow, right?
Yes, sir.
Look at the arrow. Is there any change in the length of the arrow? Do you observe? Okay, I will put it in this direction so that it is clearly visible. Okay, is it clear now? Now I am
Yes, sir.
any change in the length of that arrow, green arrow? Is there any change in the length of the arrow? Hello? Hello?
Yes, sir. It became longer.
Is
No,
it?
it's going up.
Okay, just it is going up. I am asking about the length of that arrow.
No, sir. No, sir.
No change means no change in the magnitude of the magnitude of the magnetic field, right?
Yes, sir.
So force is not changed, but I am changing the location of observation or point of observation. I am just increasing the height. So whatever may be the position, but if I change the radius, means I am moving away from the conductor, right? I am increasing the radius means I am moving away from the conductor. When I am very close to the conductor, what is the length of that arrow? You can see. Is it increasing or not?
Yes, sir.
Yeah, that indicates that magnetic force is very high when we are very close to the conductor. If I am moving away from the conductor, the force is very less, very less. If I move away, then at some point, almost that magnetic force will become zero, right?
Yes, sir.
So is it clear now that at some
Yes, sir.
point, definitely magnetic force will become zero. So that point is called a neutral point. Whenever there is a point at which magnetic field is zero, is called a neutral point, right?
Yes, sir.
So I am able to see the magnetic field in circular path, right? That is the field lines. Field lines are like concentric circles. The direction of magnetic force is always tangent to that circular path, right?
Yes,
Or
sir.
circulating magnetic field. It indicates that magnetic force is always changing its direction. For which? For a straight conductor in which current is passing, isn't it?
Yes, sir.
So in the case of a straight conductor, which is having some current in flowing through it, definitely it produces magnetic field. This magnetic field is in the direction of tangent, right?
Yes, sir.
The magnetic field lines are nothing but concentric circles. The concentric circles are very dense when we are close to the conductor. So close to the conductor, the magnetic field lines are very dense, indicating that magnetic force is large.
Sir, you're not audible. Sir, your voice is breaking. Sir, you are not audible, sir.
Am I audible?
Sir, your voice is breaking.
Yeah. So yes.
Sir, your voice is
Hello.
breaking still, sir.
Is it okay? At least now.
Better, sir, better.
Yeah. Now it is coming up. Internet. That Wi-Fi is working now. Right. So the point once again still not solved, isn't it? How
Yes,
much?
sir.
How much? Now one point is confirmed that magnetic force, I can say B. Sometimes I write it as H. Okay, what is the exact difference between the two? That will be get clarified later, right? So for now, this is called B. There is decrease of B as distance increases, right?
Yes, sir.
Okay, how much? Is there any proportionality? Means, is it having the relation like this? Because one is increasing, one is decreasing, right? If one is decreasing,
Yes,
another
sir.
is increasing. Is the relation is like this? B is proportional to 1 by D. What do you think? What do you guess? What is your wild guess? Is it correct? Do you think is it correct? One observation you can have from this concentric rings, right? Hello? 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 Nisha, are you there? Am I audible?
Sir, am I audible?
Yes, you are audible now.
Sir, I was talking, but you are not able to listen.
Hello?
Sir.
Yeah. Am I audible?
Yes, sir.
Is
Now
my
you are
voice?
audible.
Okay, fine. So the point I am just telling you is, do you think that this relation is correct? Hello? Hello?
Yes, sir.
Is it correct, or what do you think? What is
I
your
think it
guess?
is correct.
How?
I don't know.
How you can?
Proportionality must be made.
Okay, we confirmed that one, that as as D increases, B decreases, right?
Yes, sir.
Okay, look at these concentric circles, right?
Yes, sir.
Okay. If this is the case, what should be this spacing between these should look like?
It is decreasing, sir, slowly.
This spacing itself is decreasing, isn't it?
Yes, sir.
Right?
Yes, sir.
Then this relation, whatever B is proportional to 1 by D, is correct?
Yes, sir.
Sure?
Yes, sir.
Okay. So you remember this point, and then we discuss more tomorrow, right? Because still a few more worksheets I have to complete by today night.
Yes, sir.
Okay, for now I will be stopping for today. Tomorrow I go with 2 hours complete session, right?
Yes, sir.
Almost we prepared even that mathematics worksheets, all are ready now.
Yes, sir.
Soon, I think once again I remind, and then I share a few of the worksheets to your mail, right?
Sir, should I send my mail again in chat?
Yeah, I have, no
Okay,
problem,
sir. Okay, sir.
because I already saved, right?
Yes, sir.
Yeah, I am good. Even this one, this link.
Yes, sir.
Okay, I share today. I share which topic that I can share.
Anything is fine, sir.
Anything is fine. Okay, so choice is mine.
Yes, sir.
Or you have any choice?
No, sir.
Okay, I will share some of the worksheets, and then, so when will you submit?
Sir, like I'm having exams non-stop, sir. I will try to finish them if I have time.
When?
That I'm not sure, sir.
Still not sure. What the final exams are going, or
Pre-boards, sir.
Pre-board exams. Okay, when are the board exams?
April 26th.
April 26th. So by April 12, you are finishing pre-board exam.
Yes, sir.
12 to 26, you have the time, but you may be preparing for the board exams, right?
Yes, sir.
Then,
I'll take time and I'll finish them, sir, in like 3 days or something.
so when do I expect? After 12th of this month, April, or before 12th?
Before
Or,
only, sir. Before only.
okay, so by 12th, I will be getting all the completed worksheets from your side, right?
Yes, sir.
Okay, that's good. And I note it down. So, okay, I remembered the time. Before 12, you try to submit, but just 2 or 3 more days, that is enough for me to complete everything, because I am just slowing down a bit, right?
Yes,
The,
sir.
the thing is, only the thing is, I have to evaluate how much improvement is there in your case, right?
Yes, sir.
So that evaluation is also needed. I don't 100% evaluate it, but whenever not only the questions that I am giving in the sheet, you try to even elaborate whenever you think it is necessary, because you are informed with so much of information, so much of interaction that also happened. You try to elaborate that also, right?
Yes, sir.
So don't stick only to that questions, because the questions are now very limited. In the second level of that one, I am increasing that one further. Any chance of using that tools that I already shared with you?
Yes, sir. From tomorrow, I will be able to use tools.
Which, okay, what I am asking is, tomorrow you will be using the
Website,
tools,
yes, sir.
okay, yeah, the site or whatever it is that you will be using, and that I will be sharing the link, and then you will be doing and submitting 1 or 2 tomorrow,
Yes, sir.
right? So
Yes, sir.
class submission, that is. Another tool I shared with you already. Did you find any time that
That
analyze
flow chart one, sir.
analyze
That I didn't do yet, so
Okay, so you haven't.
no, sir.
Okay, if possible, you try that one also. Okay,
Yes.
anyhow, or otherwise we focus after the exams, after April 22nd or so, right?
Yes, sir.
By that time, I also will be having some leisure, right? I will be discussing more points, and then we try to improve further, right?
Yes, sir.
So today I take leave, and I am stopping the screen share,
Yes, sir.
right? I stopped it.
Yes, sir.
So today I am sharing few of the worksheets, few from maths, few from physics, and few from chemistry. Like that I do.
Yes, sir.
So you try to complete and share them as early as possible. So when I am sharing through mail means you can send me through mail also. If
Yes, sir. The same mail ID.
yeah, same mail ID.
Yes, sir.
That will be easier, because submission through that one will be easier, or you can submit in that, because we are not linked to any schedules.
Yes,
Submission
sir.
to mail will be easier for you, right?
Yes, sir. It is easy. You can send big files also.
Yes, you can do, right?
Yes,
Okay,
sir.
so take care, and then bye. I am taking leave for
Thank you,
today.
sir.
Thank you.